we will today solve a problem of root locus. The problem is the open loop transfer function of a unity feedback control system is given by GSHS, which is equals to K divided by S into S square plus 6S plus 25. This is the given problem. This is the open loop transfer function of a control system, and the question is asking about to draw the root locus. This is the problem. So we will go as per our procedure. There are 10 number of steps to draw the root locus. First we have to calculate and find out the values for 10 steps. So the point number 1 first. So the solution is point number 1. Point number 1 is about poles. So I am writing here P equals to, I can see here, since the denominator part has the order of 3, so the P equals to 3. And what are the poles? The poles are, I can directly see one single S, so 1 is 0, and the other part S square plus 6S plus 25. By finding this solution in any calculator, you can find out the roots. That is a complex value, complex pole will come out. The values are, this is -3. I have already calculated previously, so I know the values. -3 plus and minus G4. So this is actually 3 number of poles. One is 0, the second one is -3 plus J4, and the third one is -3 minus J4. So 3 number of poles are there. The second point in our solution, or step number 2, is number of zeros, and there is no S term in the numerator part. The zeros is 0, no requirement for any further. And point number 3 states about the number of branches of the root locus, or how many root locus branches exist in this root locus given by this program. So n equals to, here the formula is n is higher of P or Z, and here we can see that P is higher, so n equals to P, which equals to 3. Then point number 4 states about the existence of root locus on real axis. This is the statement of the heading of the point number 4, and for this we have to draw in a rough the S plane. This is the real axis, this is the imaginary axis, and here we have to mark the poles and zeros. Since only poles are there, we have to mark the poles. One pole present at the origin, and the other poles we have to just do the common marking. 1 2 3 4, 1 2 3 4. This is -3, this is plus G4 minus G4. So the combination here, the poles are here. So by visualizing the position of the poles and starting from a left side of the S plane, I consider a section, small section here, and from this section, how many number of poles and zeros present to the right of this section. The section is, let's say this is small section, and from this section, how many poles and zeros present to the right of this section. So I can count 1 2 3. So 3 is an odd number. If total number of poles and zeros to the right of the section is odd, then root locus exists, and the same condition can be extended till -3. When I reach -3, 2 number of poles are on the point. That means only 1 number of poles present to the right of that section when I reach the section exactly at -3. So then also the total number of poles and zeros becomes 1. That is also odd number. So the root locus also exists from this point to this point, and this point can be extended to -infinity. When I reach the origin, total number of poles and zeros becomes 0 to the right of that section. So 0 is considered as an even number and root locus does not exist. So I can write, first I can mark this, that root locus exists till 0 to minus infinity. So I can write here the root locus exists between minus infinity to 0 in the real axis. Okay, this is about point number 4. Then we will go to point number 5. Point number 5 is about point number 5 is about breakpoint. To find the breakpoint, we have to find the characteristic equation. The characteristic equation will be find out from this, that is 1 plus GSHS equals to 0, 1 plus GSHS equals to 1 plus k divided by s into s square plus 6s plus 25. So if I then the characteristic equation is 1 plus GSHS equals to 0. This implies that 1 plus k by s square, s into s square plus 6s plus 25 equals to 0. This implies that I expand this, s cube plus 6s square plus 25s plus k equals to 0. This is the characteristic equation. That in the explanation to find the breakpoint, I have already mentioned in my previous video that we should rewrite this characteristic equation in terms of k, and k equals to becomes, from this equation, k becomes minus of s cube plus 6s square plus 25s. So then we have to find out dk by ds, which is minus of 3s square plus 12s plus 25. Now we have to find out the solution for dk by ds equals to 0. Finding the solution for dk by ds equals to 0. That means 3s square. Now since we are equating to 0, so minus signs cancelled out. 3s square plus 12s plus 25 equals to 0. This implies that again we can find the values of this s in by using calculator. If you use the calculator in equation mode, we can find out directly. That is, the solution are s1 equals to, I have already find out, minus 2 plus, and s1 is plus 2.08 j and s2 is minus 2 minus j 2.08. So these are the solution for this breakpoint, but this minus 2 plus j 2.08 and minus 2 minus j 2.08 is not in the real axis, and for the breakpoint to be valid, it must lie in the real axis. Since these solutions are in complex zone, so these are not valid breakpoints. Okay, so this breakpoint does not exist for this particular problem. For this problem, breakpoint does not exist. Then we will go to the next point. The next point is about the centroid. Point number 6, centroid. For centroid, the formula is summation of poles minus summation of zeros divided by p minus z. And what are the poles and zeros? The poles are only poles present, no zeros. So 0, minus 3 plus J4 and minus 3 minus J4. So I will write that 0 plus bracketed minus 3 plus J4 plus minus 3 minus J4 in the bracket. Since no zeros are there, I omit the second part. P minus Z, P equals to 3 and Z equals to 0. So P becomes 3 minus Z is 0. When I expand this, 0 minus 3 plus J4 plus, again this becomes minus J4 by 3. This part is cancelled out. Minus 6 by 3 equals to minus 2. So minus 2 is the centroid. And what is centroid? At centroid we draw the asymptotic lines. Asymptotic lines are the imaginary lines which are drawn to assume the root locus branches follows when the k approaches infinity. So we have to next find out the asymptotic lines angle or angle of asymptotes. Angle of asymptotes. The formula is theta k equals to 180 degree into 2k plus 1 divided by p minus z, and where the value of k is extended from 0, 1, 2 up to p minus z minus 1. So where p equals to 3 and z equals to 0, so p minus z minus 1 equals to 3 minus 0 minus 1 equals to 2. So k of the values of k are 0, 1 and 2. So I correspondingly write theta 0 equals to 180 degree into 1, 0 into 0 plus 1 equals to 1 by 3 equals to 60 degree, and theta 1 equals to 180 degree into 3 by 3 equals to 180 degree, and theta 2 equals to 180 degree into 5 by 3 equals to, it will find out to be 300 degree. This is point number 7. Then we will go to the next point, point number 8. The point number 8 is, it is about imaginary axis crossover point. Imaginary axis crossover point. And how we find out this? It will be find out using or applying root array to the characteristic equation. And the characteristic equation is, we have already find out in our previous JK points. That is the characteristic equation, s cube plus 6x square plus 25s plus k. So I apply the values s cube plus 6s square plus 25s plus k equals to 0. This is the characteristic equation. Apply the root array to this equation is s cube s square. I write this first two term, that is, and corresponding odd power coefficient and even power coefficient, s cube 1, 25s. So I write here 25, here 6, here k, and I will find out the s1 row and s0 row. S1 row becomes 6 into 25, 6 into 25 minus k divided by 6, that is 150 minus k by 6, and the second s0 term becomes, that is this term, that is becomes k. For a system to be stable, for stable system, all the elements of the first column must be greater than 0 or in same sign. Actually 1 and 6 are already in positive sign, so these two must also be positive. That means k must greater than 0, which is always true, and the second condition must be 150 minus k by 6 must be greater than 0. This implies that 150 minus k must greater than 0, which equal to k must be less than 150. So for a stable system, or I can say the system which is given by this problem is stable up to 0 to 150. Beyond 150, the system becomes unstable. So at which point this root locus which we are going to draw will cross the imaginary axis which point the imaginary axis crosses the root locus crosses the imaginary axis is determined from the square row equation by putting the value of k, the range of k in this value. So this is 6s square plus k equals to 0. Finding for the solution, this implies that s square is 6s square plus k is 150. 150 equals to 0. This implies that s square equals to minus 25 and s equals to minus j plus minus j5. So these are the solution for imaginary axis crossover point, and the value of k is k. At k equals to 150, the root locus branches crosses the imaginary axis at s equals to j5. And the next point, actually this is the last point, and the last point will be point number 9. Point number 9 is about angle of departure from complex pole. This point I have not discussed in my previous problem, because in that problem the point number 9 does not require. So I have to explain the point. To find out this angle of departure from complex pole, there must be some complex pole present. In this case, complex pole are there. That is, there are two number of complex pole. One is minus 3 plus G4, another is minus 3 minus G4. So there are two number of angle of departure will come out for each and every complex pole. The first one is phi d. The angle of departure is represented by phi d, and phi d for minus 3 plus G4, and the second one is phi d minus 3 minus J4. These are the complex poles and corresponding complex is the angle of departure from complex pole. So we will go for the first one. This one will first. Actually, finding for one will ultimately give the answer for the second. Then what is the procedure to find this angle of departure? For this we have to draw another in the rough and mark the poles. Poles is at 0 is 1 2 3 1 2 3 4 1 2 3 4. This is only rough side. Minus J4 plus J4 minus 3, and this is at this point and this point. This is minus 3 plus J4. As we are finding for minus 3 plus J4 complex pole, we just joined from this pole all other poles. We joined all other poles. If zeros are also present, and we have to also join that, but here no zeros are there. And the formula for this phi d is statement. This is a statement. The statement is 180 degree minus sum of all angles subtended by remaining poles minus sum of all angles subtended by zeros. This is the formula. Sum of all angles subtended by remaining poles minus sum of all angles subtended by zeros. This will come in the bracket, and this total thing is 180 degree minus this one. So we have to find out this, but since only poles are there, the second part will not come. Sum of all angles obtained by zeros are not there, so I have to only consider the sum of all angles obtained by remaining poles, and there are 3 number of poles. So I have to write here what are the number of angles obtained by remaining poles is. This is the first angle, I write here theta 1, and this one is the second one, theta 2. Only 2 number of angles are there. This is 180 degree minus theta 1 plus theta 2. This is the formula. So I have to find out theta 1 and theta 2. What is theta 1? Theta 1 equals to, I can see that this is this angle. If I write here theta, it is theta 1 equals to 180 degree minus theta from this if I consider this as theta. So theta and theta 1 equals total summation of theta plus theta 1 equals to 180 degree. So theta 1 is 180 degree minus theta. And what is theta? Theta is tan inverse of 4 by 3, because this is angle tan inverse 4 by 3. So this becomes 180 degree minus tan inverse 4 by 3. And the solution for tan inverse 4 by 3 is 1. I am writing 180 degree minus, the solution is already find out, it is come out to be 53.06 degree. Okay, so the solution for theta 1 becomes 126.94 degree, and the second one theta 2 we can visualize that it is 90 degree theta 2. So I can write here theta 2 equals to 90 degree. Okay, so I can write the solution for theta d, for which I am finding for phi, actually phi d for minus 3 plus j4 equals to 180 degree minus theta 1 plus theta 2 is equals to 180 degree minus 126.94 plus 90 degree, which comes out to be, the solution is minus 36.94 degree. Okay, this is for the minus 3 plus j4 poles. Similarly, we have to find out the other one, that is minus 3 minus j4, but since both the poles, complex poles, are conjugate pairs, the ultimate finding will be inverse of this one. So phi d for minus 3j equals to, it will be find out as just 36.94, just the sign will be inverse 36.94 degrees. So these are all about our the findings. The point number 10 will not come out as there is no complex zeros, actually no zeros are present, so only 9 points are there. So first point 3, the second point 0, the solution or findings, the third point is 3, the root locus exists between minus infinity to 0. Then the point number 5 is about a breakpoint, there is no valid breakpoint, point number 5 is not comes out. And point number 6, the centroid, it is minus 2. Then point number 7, angle of asymptotes, are found out to be minus 60 degree, minus 180 degree, 60 degree, 180 degree, and 300 degree. These are 3 angle of asymptotes. In point number 8, imaginary axis crossover point, it is found out from root array, and we have find out the solution for k at which the root locus will crosses the imaginary axis is k equals to 150, and at which point it will cross, at s equals to plus and minus j5 it will cross. So these are the findings till point number 8, and the point number 9 is angle of departure. We have already find out the angle of departure to be for minus 3J4 poles, the angle of departure is minus 36.94 degree, and for 5D minus 3 minus 3J, it is 36.94 degrees. So these are all about the solution, individual points. Then we have to draw the, just one second, we have to draw the graph. For the graph, we have to, in the graph paper, just draw the real axis in the middle and towards the right side draw the imaginary axis. Okay, I am just drawing in a rough section, but you should draw in a graph paper. Just you have to mark as usual the axis. For x-axis, take the units. For y-axis, takes the units corresponding in the graph paper. You have to write. I am, since using simple rock paper, I can mark this. Since it is one pole is present at 0, this is minus 3, this is 1 2 3 4 plus J4, 1 2 3 4 minus J4. This is the real axis and this is the imaginary axis. These are the markings and the pole, complex pole present here. Okay, these are already we have drawn in the rough section also. Then we have to mark the findings. We have already marked the poles 1 2 3 number of poles. Point number 2 does not require. Point number 3 already, it will come out as a freehand drawing. It will come out at the end of all the points are marked. Then we go to the point number 4. Point number 4 is about the break point, is the existence of real axis. That is, we have to mark existence of real axis. It will come out in the real axis. We have to dark the negative real axis. We have to dark the negative real axis, and we will give the arrow and mark here minus infinity in this way, and at this point it is k equals to 0. Okay, and there is no breakpoints. There is no breakpoint and only centroid is there. Point number 5 does not come out. No breakpoint, no valid breakpoint. This point is in the root locus but not in the real axis, so it is not valid breakpoint. And point number 6, centroids come out to be minus 2, and the angles are minus 60 degree, 180 degree, and 300 degree. So we have to mark the minus 2 is the centroid. This is the point centroid, and at this centroid we have to draw the angles. The angles are 60 degree, 180 degree, and 300 degree. Just I am drawing in a rough paper that these are come out to be. Just have to verify. Since we have already found out the imaginary axis crossover point, it is crossing near J5. It will come out like this. The 60 degree. This angle is 60 degree. The 180 degree this section. This is 180 degree, and the third angle will be 300 degrees. Like this will come out. We can use a protractor to draw these lines. Okay, and this line can be in dotted form, in small sets, not dark sets. Then these are the asymptotic lines we have already drawn. Then the imaginary crossover point is at 1 2 3 4 5. This is the point of cross section. At this point the root locus branch cross. Similarly here also there is another point. This is minus J5. This is plus J5. This is the point of cross section. At this point, what is the value of k? K equals to 150. At this value, k equals to 150. And what is the last point? The last point is this is already we have mentioned imaginary axis crossover point. The last one is angle of departure. Angle of departure we have find out as minus 36.94 for minus 3 J4. So I draw here. Here also you can draw the angle using a protractor, and since it is minus we have to draw in the negative side. I am just using a protractor, draw the angle. This angle is 36 minus 36.94 degree, and see this is the angle. And similarly for this angle, the second one, for the angle the poles minus 3J, the angle will be positive. So this is the angle 36.94 degree. So now all the findings are marked. All the findings are marked. Now we can draw the freehand drawing. One branch is already drawn, that is from center, the origin to minus infinity. There are two other branches. One branch comes from this, it will crosses through the plus J5 and minus J5 point and match the asymptotic lines in the infinity when k becomes infinity. So I just draw the freehand drawing. The angle of departure already we have drawn this, and it will match the imaginary axis crossover point, and it will ultimately match the asymptotic lines. We just draw in freehand, and only thing we have to consider is the drawing what we have drawn in the positive imaginary side, or that is upper half of the real axis, upper side, whatever we have drawn, the lower side should be just mirror image of the same. These are all the drawings. This is one branch, this is second branch, and this is third branch. Only we have to mark the corresponding values of k. Here k equals to 0, here k equals to, I have already mentioned, 150, and here the k becomes infinity. Here also it will comes like k equals to infinity. So this is all about the drawing for the root locus for the corresponding problem. Okay, thank you.